Hello everyone. In this lesson, we're going to solve some problems based on annuity due. Annuity due is when we make payments in the beginning of the payment interval. We'll cover two types of annuity due. One is simple annuity and second is general annuity. My first question is, what accumulated value can be expected after 5 years of quarterly payments of 2000 made at the beginning of each quarter if the interest rate is 5.5% compounded quarterly? Now this is a case of beginning. So this is annuity due. To solve such problems using the calculator, we need to make sure our calculator is at the beginning mode. This calculator is dead, but I'll show you the steps. Okay, so to set your calculator at beginning mode, you'll press Shift, then PMT. Your screen will display end. Okay, now again use Shift key and then enter. Your screen will show BGN here, which means beginning, right? Because you want beginning mode. So at this point you need to quit. Okay, for that you will use Shift and then quit. You will see a little icon of BGN here on your screen. Okay, BGN means beginning. If nothing is displayed here, that means your calculator is on end mode. Okay, so make sure in all questions of annuity due, you set your calculator at BGN mode. Okay, once you set your calculator at BGN mode, we'll write down the variables, these variables, right? And then the information of these variables. Now the question says, what accumulated value? That means we need to calculate future value, right? So future value is question mark here. Time is 5 years and the payments are made quarterly, right? So 4 payments in a year. So 5 times 4 will give you n, right? Then 2000 is the payment size. So PMT is 2000. Then rate of interest is 5.5%. So we'll write down IY is 5.5, right? Now to set PY and CY, in this case, the payments are made quarterly and also the interest is compounded quarterly. So payment interval, which is 4, is equal to compounding interval, which is again 4. So it is a case of simple annuity. Okay, so PY is 4, CY is 4. To set this in your calculator, your steps will be 5 times 4 equals, your screen will display 20. That 20 is our value of n. So you will press n. Your screen will display n is equal to 20. Now next step, enter IY 5.5, right? And then press IY. Your screen will display IY is equal to 5.5. Next, to set PY equal to 4, use Shift and then IY, which means PY will be displayed. So PY should be 4. If your screen displays different value, press 4 and then enter. Your screen will display PY is equal to 4. Now you scroll down using the down arrow key. Okay, your screen will display CY. By default, it takes value equal to PY. Okay, so make sure this value is the right value what you want. In this question, we want CY equal to 4. So that is our value. Now we'll quit. So Shift, quit. Okay, next step, 0 is PV. Then press 2000, right? And then PMT. So once we entered all the data, we need to find out the value of FV, right? So compute FV. your screen will display negative 46,310.53. Okay, so accumulated value is positive 46,310.53 cents. My next question is, Rihanna has just graduated law school and has 85,000 in student loan. Her intention is to have the loans paid off by her 30th birthday, which is in 4.5 years. If she starts making payments today and the rate on student loan is 2.4%, what will be her monthly payment? Now, because she wants to start making payments today, that means it is a case of annuity due, right? So beginning means annuity due. Second thing is payments are made monthly, right? So payment interval is a month. Also, it doesn't say anything about compounding period here. So we'll consider this is equal to monthly payment. So compounding frequency is equal to payment interval. It is a case of simple annuity. Now let's write down the values of all the variables. N is 12 payments in a year times 4.5 years. Then IY is 2.4. Now using shift key, you will enter payments per year, which is 12. Then use down arrow key to enter compoundings per year, which is again 12. PV is 85,000, that is her loan. We want to calculate the size of payments, so this is our question mark. Future value is 0. When we do compute PMT, payment size comes out to be 1,658.86 cents. Next question. Shawna decides to save for her daughter's education by depositing $50 at the beginning of each month. That pays 6.25% compounded quarterly. How much will be in the account after 10 years have passed? How much in the account? That means we need to figure out the future value, right? It is a case of beginning, so it is annuity due. Second thing we need to notice here is payments are made every month, whereas the rate of interest is compounded quarterly. So payment interval does not match with compounding frequency. So it is a case of general annuity, right? Compounding frequency is not equal to payment interval. So it is a case of general annuity. Combining these two, it is a case of general annuity due. Let's write down the values of variables. Now N is, because she's making 12 payments in a year, so 12 times how many years in total? 10 years. So 12 times 10. IY is 6.25. Interest per year is 6.25. Then values of payment per years. Because she's making monthly payments, so payments per year is equal to 12. And scroll down. Compounding per year should be 4 here. Please pay attention. These two values are different in this case because it is a case of general annuity. Okay, so payment per year is 12, compounding per year is equal to 4 because the rate of interest is compounded quarterly. Quarterly means 4 times. Okay, so CY is 4. Previous value is or present value is 0 and then payment size is 50. We want to calculate the accumulated money, that is the future value. When you compute future value, you get 8,334.47 cents. Please feel free to pause the video and enter all these values in your calculator to compute future value. Another question. Sarah makes a New Year's resolution to deposit 500 every quarter into mutual fund that has averaged 11.5% compounded monthly. The first deposit will be made on January 1st. How much will the fund be worth when she retires on September 30th? Okay, so starting from January 1st, we need to calculate the time between these two dates. Okay, because she's making first deposit on this date, that is in the beginning, so it is a case of annuity due. One thing. Second thing is payments are made every quarter, whereas the interest is compounded monthly. So they do not match, right? It is a case of general annuity. So here we have the information. It is a case of annuity due and it is a case of general annuity. When we enter all the values, now watch another video to calculate the time between two dates. When I calculate time between January 1st, 2010 and September 30, 2022, it comes out to be 12.75 years. Okay, because the payments are made quarterly, so 4 times this gives you 51. Then interest per year 11.5, payments per year because she's making quarterly payments, so payments per year is equal to 4, compounding per year 12, right, because it is compounded monthly, so 12 times in a year. Present value is 0, payment is 500, future value we need to figure out. When we compute future value, this comes out to be this value. Okay, I'll show you the steps now to calculate the time between these two dates. I'll use the dead keys, but you can use your actual calculator. Okay, so we'll start with shift, then date. Your screen will display date 1. To enter this value, you will enter the number for the month first. So January is first month, so you will enter 1 dot. Now the date, which is 01. Now the year is 10, so enter 10. Scroll down, enter second date, which is 9 dot 30 22, right? Okay, now scroll down, you will get DBT, which is 4655 divided by 365, okay, to get the number of years. You will get 12.75 years times 4 gives you value of n. Okay, this is the time to check your understanding. Please pause the video, identify the type of the annuity, write down the values of all the variables and compute what is required. Okay, welcome back everyone. So here is the solution. Thank you everyone.